It's
Yeah,
visible?
yes, we can see it. Yes.
Okay. Sorry for the problem technique. So there's first, I think we prepared this work in this oncology conference. Our conference is the impact of contamination particles in the built-up region. This work was prepared by Mustafha, Assalmi, and Yamani Dia from multidisciplinary faculty, Mohammed University. So I present this work under the following outline. After introduction, the second part will be devoted to the methods and material used in the preparation of this work. Then the third part will be focused on the results and discussion, and will be end the conclusion of this work. So radiotherapy consists in principle of to irradiating the tumor volume by ionizing radiation. The beam of radiation is regulated in energy and size according to the depth of the tumor. So the objective of this work was to study the divergence between Monte Carlo simulation and experimental measurements in the built-up region using two types of medical accelerators, Electa Synergy MLCI2 and variant Clinac 21C00C, and also for two types of ionization chambers. So, of course, in Monte Carlo simulation, each element of the Linac geometry is modeled with its true dimension and material composition. The Linac geometry studied in this work is Electa Synergy and variant Clinic 2100C. So the geometry information for Electa was obtained under a confidentiality agreement with company Electa AB Stockholm, Sweden, and variant. It's of course an old model of the medical accelerator. Its geometry is now available in the GMT4. So the Monte Carlo could use it in this work. You hear me? Hello? You hear me? I can continue?
Yes, we can hear you. You can continue.
Well, there. So the Monte Carlo could use it in this work is the GT4 Linac MT. This code is programmed in C++ and has a Java PASIC interface to facilitate the use of this code. We use this code to modeling the variant Linac and Electa synergy geometries. So, right. So the Monte Carlo calculation are carried out using the Moroccan high-performance computing grid connected with the Marwan network. Consists of the 19 nodes performed or use it to perform the calculation, Monte Carlo calculation. So the measurements data for Electa Synergy MLCI2 carried out the ionization chamber EBA CC13 for different size and phantom tape blue phantom 2, and data acquisition is performed by Make Accept software. So the experimental dose measurement for the Linac variant are performed by Semiflex 3D ionization chamber. In this, the water phantom tape beam scan data acquisition is performed by Mephisto software. So the dose, of course, is defined by main energy absorbed in volume on the mass of this volume. This dose expressed, of course, by gray. The comparison between the dose simulated by the Monte Carlo simulation and experimental measurements are based on the main 20-point dose error in the gamma index fixed and 2% on 2 millimeter. So the results of the validation Monte Carlo by experimental measurements in different fields, size fields for Electa synergy MLC dosimetry and experimental measurements carried out by GNT4 Linux AMT for 6 megavolt. Here we can see here clearly that the large divergence between Monte Carlo simulation and experimental measurements is located in the built-up region. So the effect of the contamination particles in this region was studied according to the ionization chambers, surface to the distance SSD, size of the irradiation field, and energy, beam energy 6 and 19 megavolt. So we studied those divergences between Monte Carlo simulation and experimental measurement in this region by placing a series of phase space plays at different depths in the built-up region. So we now pass to first case. We have studied here two types of ionization chamber for different sizes, semiflexoid D and EVA CC13. We compared those distribution at the depth in the build-up region between Monte Carlo simulation and experimental measurements. It's clear that the difference in those between simulation and the measurements decreases with depth due to the appearance of contamination particles. So, as I noted, that the particles are created by the interaction of photons with the component of the LINAC. The photons are created by the interaction of accelerated electron with target. Secondary created particle can also induce interaction and create photon and the process and continue, of course. So this table shows the original of production of particles crossing the phase space plane placed on the phantom surface of 19 centimeter. So the percentage of each particles is calculated relative to the number of particles collected in the phase space plane. So this rapid variation of the particles affects the dose accuracy in the built-up region. So here in this table, we show the average energy in percentage of collected particles in the phase space at different depths of varying and Electa accelerators. We have placed a plan of phase space at different depths in which we can see that the number of photons decreases and the number of contamination particles increases with depths. So to analyze this data, we place it in, we show in this table the difference in number of contamination particles between two consecutive depths between, or we can see clearly that the number of particles stabilizes with depth and become almost equal between 10 and 15 millimeter. In depth of build-up region, of course. At this depth, we have the equilibrium electron, and therefore the divergence between Monte Carlo simulations and experimental measurement decreases. So we pass now to the second case, the distance to source surface SSD. So here the figure shows the depth dose comparison in the two source to surface 19 and 100 centimeter. So we compare the effect of 10 centimeter of air on the appearance of the contamination particles. The gamma index shows that the divergence is high for the distance of 19 centimeter. And the spectrum shows that the difference in distance of 10 centimeter and air influence the intensity of electron number which is logical that the path of the electrons is very weak. On the other hand, the photon have a length path on the matter, and therefore 10 centimeter of air does not have any effect on the intensity number of photons, which are, bien sûr, it's logical. So here we show in this figure the statistical of the particles in the different depths in the built-up region. The figure shows the number of contamination particles according to the depth of the built-up region. It's clear that from the results, the difference in the percentage of electron and positron, it's just in the first 2 millimeters depth of the water phantom, which is explained by the particles which stop in the 10 centimeter